Welcome to lesson number 4. Today we are looking at combining the exponent laws. In part 1, we have 3 students who are attempting to simplify this expression, 3x squared times 5x cubed. Their answers are shown below. We have Harry, who has an answer of 8x to the power of 5, Janet, who has an answer of 15x to the power of 6, and Laura, who has an answer of 15x to the power of 5. So it appears that Harry he has the sum of the 3 and this 5 as 8, so he added the coefficients. Janet multiplied the coefficients, and Laura also multiplied the coefficients. And so what we're really looking at here is what are they doing with the exponents? So explain using factors which student is correct. Now, when I was writing this out, I was looking at Laura's answer, and I wrote the factor out as 5x to the power of 5. However, this should be 5x cubed that I write here. And so I should get rid of this and this. And then when we simplify, what we get is 3 times 5, which is our 15, coefficient of 15. However, when we combine the x's, there's only 1, 2, 3, 4, 5 x's. 1, 2, 3, 4, 5 x's, and so we get rid of 2 of those, and we're left with 15x to the power of 5, which means that Laura is correct. Now, we want to, in this part 2, we want to use factors to explain why 6a to the power of 6 divided by 3a squared is equal to 2a divided by 4. Well, if we set this up using factors, then this is going to be 6 with 6 a's multiplying each other, divided by 3 and 2 a's that multiply each other. 3 and 6, so 6 divided by 3 would be 2, and then I would cancel out 2 of my a's, leave me with 1, 2, 3, 4 a's, 2a to the power of 4. Now, with class example number 1, we want to state the simplified form of the following. So I have negative 7a to the power of 8 times 6a to the power of 12. The first thing we want to do is remember, just like up here, we multiply our coefficients by one another. So we would have 7 multiplied by 6 would leave us with negative 42. And if I combine my exponents, a and a, so I have a base of a, and 8 plus 12 would give me 20. So negative 42a to the power of 20. Now I have 3a to the power of 4 times 5a to the power of 5 times 6 to the power a to the power of 3. So again, multiply our coefficients. 3, this one has a coefficient of 1, and 6 will leave us with 18. And then we got to combine our exponents on our base. So we have the base of a, 4 plus 5 is 9, plus 3 is 12. So 18a to the power of 12. And next we have negative 16n to the power of 5 divided by negative 2n. Again, we need to work with our coefficients and simplify those. So we have negative 16 divided by negative 2, which would give us positive 8. And because we're dividing here, we need to subtract our exponents. And so we have an exponent of 5, and that n has an exponent of 1 there. So 5 minus 1 would be 4. And here we would do the same thing as we did in part C, where we have the quotient law we need to apply. 20 divided by 5 is 4. And then y to the power of 5 and y to the power of 5. We have 5 minus 5, which would be y to the power of 0. And y to the power of 0 is just 1, so we would just be left with 4. And now we have 30b to the power of 14 divided by 45b to the power of 10. We could just simplify this, and so if we think about the number 15, we can simplify 15 goes into 30 2 times, goes into 45 3 times, so that's going to be 2/3, and 2/3 using the quotient law with my exponents would be b to the power of 14 minus 10, or b to the power of 4. In class example number 2, we want to simplify the following. we have x to the power of 5, y to the power of 8, x cubed, y to the power of 4. Now, here we have two different bases, and so we're going to combine the like terms. So the x's, and we can apply the product law. So this is going to be x 5 plus 3 is 8, and y 8 plus 4 is 12. Same thing with this next problem. We have x 5 minus 3, which would be x squared, and y to the power of 8 divided by y would be y to the power of 8 minus 1, or 7. Here we have negative 3bc times b cubed c squared times negative 4b squared c. Again, we are going to combine our coefficients. So negative 3 times negative 4 will be positive 12. And then we need to combine all the b's. So b cubed, b squared. This is going to be b to the power of 6, because we have 1 plus 3 is 4 plus 2 is 6. And then we have 1c, 2 c's, and another c. That will be c. 1 plus 2 is 3 plus another one is 4. And this last one we can also simplify. I have 2's that go into 10 and 4, which would be 5 over 2. I have e, which is e to the power of 8 divided by e to the power of 4 would be e to the power of 4. And I would have f, 12 minus 7 would be to the power of 5. Now, I'm not going to do all the examples here. I'll just do the first few, and then maybe we'll do the last two, and you can figure out the middle two by yourselves, or you can ask me in class. Now what we want to do is we want to use the following examples that use two or more of the exponent laws in their solution and solve. So we want to simplify 3x squared to the power of 3. Now, remember when you see a 3 like this, there's actually an exponent of 1 on it. When we see that, we need to distribute my exponent on the outside of the brackets into both of the exponents or powers on the inside of the brackets. So this is going to become 3 to the power of 1 times 3, which is 3, and x to the power of 2 times 3, which is 6. And when we simplify that, we get 27 x to the power of 6. Now we need to do that same thing with each of these. So I have negative 2 a squared b cubed to the power of 2. We need to distribute that exponent into all of these powers. So negative 2 squared would be positive 4. A to the power of 4, 2 times 2. And 2 times 3 would be b to the power of 6. Next, I have c. And I have x cubed times x to the power of 5 divided by x squared times x. Now, we can right away simplify this with the product law. I can add these exponents. So this would become x, 3 plus 5 is 8, divided by x squared times x, which would be x cubed. And then I can subtract these exponents using my quotient law, which would be x to the power of, and here I'll work it out over here, 8 minus 3 and x to the power of 5. Looking at class example number 4, we want to simplify the following. Negative n squared to the power of 5. So negative n squared to the power of 5, this is going to simplify to negative, and I'm going to bring this in, multiply the 2. This is going to be negative n to the power of 10. And then I can distribute this negative sign inside, so that's negative 1 times negative 1, which is going to be positive, or n to the power of 10. Now, things get a little bit more complex when we see power of quotient law with the power of a power, with the product law and the quotient law, all in one question. So the first thing we want to do is we could simplify the inside. So first of all, we have our coefficients that we can simplify. 4 times 3 is 12, and we could say this is 12 x to the power of 6 y cubed divided by 6 x to the power of 5. And this is all to the power of 4. So right away we've simplified by getting rid of one of the coefficients. Now we can start combining the powers. I can go 6 goes into 12 2 times, so this is going to be 2. I have the x's I can take care of, so x to the power of 6 minus 5 would be x, and then I have y cubed, and all of this to the power of 4 still. Still haven't completely simplified because I now need to distribute this 4 to the 2, to the x, as well as to the 3. So 2 to the power of 4 is 16. X to the power of 1 times 4 is going to be x to the power of 4, and then y to the power of 3 times 4 is y to the power of 12. We could look at these two in class, and so let's look at class example number 5. In class example number 5, we just want to write these in their simplest form. So we have negative a to the power of 6 divided by negative a to the power of 4. So in simplest form, we would have negative a 6 minus 4, which would equal negative a squared, which would just equal a squared. Next, we have negative a to the power of 6 plus negative a to the power of 4. So we could right away simplify this and say negative a to the power of 6 divided by a to the power of 4. And when we carry out this simplification, we have 6 minus 4 and a divided by negative a, which would just be negative a squared. Last, we have negative a to the power of 7 divided by negative a cubed. If we distribute this inside, and one way we can look at this is that's negative a times negative a times negative a, which is going to end up with negative a. So negative a to the power of 7 divided by negative a cubed is equal to a negative by a negative is going to be a positive, so that's going to be a to the power of 7 minus 3 is 4. Now looking at class example number 6, in higher level math courses you may have variables that have bases and variable exponents and binomial exponents as well. When that happens, it'll look something like this, where you have your base and your exponents here that look like an equation or appear to be an equation. So when you have something like this, we can still approach it with the same bases and the same exponent laws. However, when we simplify our exponents, it's going to look a little bit different. So I have 4x plus y, and if it's the quotient law, then I need to subtract these, x minus 2y. This becomes b to the power of, well, 4 minus x would be 3x. If I distribute this negative sign into both of these, y plus 2y is going to be plus 3y. And with this next one, we would carry out the same process, however, take it steps at a time. So I would first add this exponent and this exponent, and then you could subtract these exponents after you've also added these ones.